Now, are drones safe? Now, Avetics Global specializes in drone technology with the ability to rapidly customize solutions for new. Now, this presentation will be featuring the company's work processes in place for the safe use of drones, which has enabled them to complete more than 500 projects safely so far.
Good evening, everybody. My name is Justin Chan. I'm the business development manager for Avetics Global, a Singapore-based drone services, full-service drone company. Right? So my presentation will be about the safe uses of drones in Singapore. So a brief background on Avetics itself. Avetics is a technology company that provides professional drone services in Southeast Asia. Right? We have a multidisciplinary approach, which means that we are not just a service provider. We also provide custom engineering, training of our own pilots, as well as external clients that wish to engage drones in their own work processes, as well as developing back-end R&D to support the data management, as well as the advanced flight aircraft that we are going to be employing over the course of our work. The drone outside that you see at the MOM booth is actually our custom drone, whereas at my own booth is the off-the-shelf DJI drone that we are a reseller and a distributor for as well, including the commercial station drones. So let's get started as to how to use drones safely. Before we get onto that, let's just ask ourselves, what exactly is a drone? Strictly speaking, a drone actually refers to any type of unmanned robot, right? Any type of unmanned robotic vehicle, which could be a ground drone, like I think MIR has that little ground robot that you see going around. That can be classified as a drone as well. But in modern terminology, drones are now referring to quadcopters, multi-rotocopters, where what you have are 4 or more propellers, also known as props, an ESC to manage the speed of the propellers as they are up in flight, and a flight controller. And the flight controller is the thing that revolutionized the utilization of drones. Were it not for the flight controller, there will be no way to go and do active stabilization for all these motors to act in concert with each other to react to the inputs from a user on the ground station. And that's where, with the advances in flight controller's signal fidelity and the user skill, we have been able to employ drones in an increasing number of works. Right now, drones are primarily thought of as a replacer for existing solutions. So in particular, for things like high altitude external works, you will be using drones to go and replace a guy on the scaffold or on the Spider-Man. But we ourselves, as a drone services company, over the past 4 years, we are seeing increasing numbers of applications for the use of drones, and our own clients have also fed back to us their own brainstorms. And this is a learning journey, and one of the things that, as we are all learning in the utilization of drones, is that we must be very safe with it. So just to go and quickly brief as to like the current applications of drones, there's two major things that I think everyone can understand very simply: outdoor and indoor space usage of drones. Outdoors, like I mentioned, is going to be about localized high altitude work. You have boomers, ropes, access scaffolding outside the building, so you can use a drone to go and replace a lot of the functions that require that right now, right? Alternatively, you're talking about aerial surveying, wide area utilization of drones. We want to do quick 3D mapping and 2D mapping of surfaces. So we've done a lot of work in this particular field. We are experienced in the peculiarities and the applications of it. So we do SVY21 compliant geospatial mapping, but there are other things that you can do as well, such as volumetric analysis of buildings. Within the indoor confined spaces, right, we're not just talking about a building like this. We're talking about things like, say, warehouses, or we're talking about oil tanks in particular, right? So these are things where your access is actually quite difficult. You get to the higher levels of a 3-story oil tank where there's no real internal scaffolding. You need to go and build your new scaffolding. You need to do rafting. You need to go and have climbers with specialized equipment. Drones can be used to go and change that up. But if you're going to use drones, we have to be aware how risky they can be. So here's a video that was played on Mythbusters about what the risk can be about flying drones.
back to the show, where Adam has two mid-range models most likely to be used in a commercial delivery.
On the left here is a flat, right out of the box, small model. Slightly larger is a intermediate kit level model, which comes with all the pieces you need to fly. You just have to assemble them. This one's apparently ready to fly, so I'm going to give it a shot. See how easy it actually is.
Not so easy.
Really easy to fly.
While the damage done so far is enlightening, a proof of concept is required.
Oh shit.
Juice on me.
To find out if a multi-rotor propeller could ever cause a flesh wound, Adam and Jamie have a standard-sized blade spinning at flight speed on a stick and a chicken.
I think today's lesson is going to be fairly self-explanatory. Whenever you're ready, sir.
Cheers. You are so sick.
Yeah! Check that out. That right there, my friends, that's an injury. But let's face it, we're not just talking about an injury, we're talking about lethality. Which means we're really talking about this vein right here, the jugular. Yeah. I think if we're going to continue testing, we need to make a neck as a testing platform that we can.
So yeah, drones, they're great, everyone's talking about them, but they do come with risks, right? And it's not just the risk to a human, right? It is the amount of damage that the drone can do in a commercial operation. So before I go, so I need to go and paint the nightmare doom and gloom scenario so that everyone understands that this is new technology, and we have to understand how it can be, how it can actually result in problems. So we talk about potential damage, we're talking about probability versus maximum damage, right? Probability is, will it happen? The chances of something happening in the first place, right? Here in Singapore, we used to think that our MRT was one of the best in the world, but clearly something went wrong over the past few years, and we keep on getting delays and delays, right? Clearly, risk probabilities are not fixed in stone, and we need to go and be cognizant as to how these things update over time, right? And now we talk about mean time to before failure, right? How long your drones can actually be used before they will actually have a failure event occurring, right? So this is how we internally calculate. This is a rough estimate how we internally calculate this sort of thing. So we actually have to go and engage in all manner of best practices in order to ensure that we understand how long operations can last before we need to do a complete inventory overhaul. And of course, it's not just probability, right? If there's a very high probability of me getting hit in the face by a mosquito, I don't really care. But it was the maximum damage. We already saw how much damage is with that video down there, right? But in terms of commercial applications of drones outside, one of the bigger problems is that drone strikes can cause jet failures. CAAS is very concerned about this. They are very aware about the fact that a flyaway risk of a drone, which is when the drone loses control of the signal control, or the controller loses his link with the drone, and it flies straight up in the air, it might hit a plane, and that can cause catastrophic damage. So in terms of the total damage, we must ensure that best practices are engaged in. Now, I'm here to go and share how Avetics internally analyzes risk as a whole, right? And we look at our risk in a three-factor matrix, right? Device safety, operator safety, and environmental safety, right? And like I mentioned just now, there are consequences to a failure event, fall and damage risk, flyaway risk to aeroplanes, and more importantly, if we are talking about live works, if my operations and my site require utilization of drones and I have an accident, it's not just the accident at that moment, right? It's a grounding of all my other operations that might be contingent on drone utilization, and these things scale up, right? These are the hidden costs that we all must be aware of, right? When we are trying to go and employ the new technology in the workplace. So let's start with device safety, right? Device safety means the aircraft itself, right? One of the ways you can make your aircraft safer is to use a greater degree of number of sensors. A commercial off-the-shelf drone like the Phantom 4 Pro, the latest created by the leader in drone technology, Avetics Innovations, has got 5 dimensions of sensing: sideways infrared, ultrasonic at the bottom, visual positioning sensors, and forward and backward cameras to ensure that it will not actually crash into anything. I could take my DJI model on my desk right now, take it here, fly it straight into a wall, and 5 meters before it hits the wall, it will stop dead in the air because it senses an obstacle in the way. That's an example as to how sensors can be used to go and mitigate the risk of the drones. Our custom drones that we have internally use LiDAR and other types of sensors as well to ensure that they are as safe as possible. Another method of safety is to use rotor redundancy, right? If I'm standing on two legs down here, if one of my legs goes out, I'm stable, but that's because I'm a human, right? For a flying robot, for a flying UAV, 4 rotors, if one rotor goes out, it is entirely out of balance, it will fall to the ground. You can alleviate that by using a multi-rotor setup. So, for example, our octo-rotor unit, which is visible outside, has 2 rotors stacked on each other. So if one rotor fails, the other rotors can take over. Alternatively, you can use a hexa-rotor setup, which is where the DJI Matrix 600 has got 6 rotors down there. So if any one of them fail, or at least if any 2 of them fail, they can still operate as long as they're not on the same, side of the drone as well. And the third one to go and do device safety is called tethering. Now, tethering is how we at Avetics are able to go and do operations within aero drones. Recall how I mentioned that CAAS does not allow drones to fly within 5 kilometers of airports in case it flies up into the air. A tethered drone reduces flyaway risk by not only providing a physical anchor, but also having a higher amount of signal control fidelity and by having the power supply linked to the cable itself. So if it gets disrupted, the drone will fall straight to the floor, straight to the ground, without the risk of going up to the air. Yes, it's bad if it falls to the ground, but it's better that a drone fall to the ground rather than plane. So the other aspect that I mentioned was environment safety. Now, environment safety is still a relatively new aspect, primarily because drones are very, very new in the market, as we mentioned. So one of the things we can do is called unmanned traffic management. That is the external provider, and NTU was recently featured in the news in how they're developing an unmanned traffic management with CAS to try and regulate this airspace. This is still relatively immature, and this is a NASA proof of concept when you're exploring various ways to go and develop this. This is still in its infancy. The other aspect of environment safety is knowledge of the local weather conditions. All right. So, in particular, when it comes to buildings, wind flow patterns can actually greatly affect the flight capability of your device. Now, these are things that we can't see with our naked eye, and we have no reason to know that when we are down on the ground. But at high altitudes, as you can see, the wind flows around buildings, it creates vortices, it creates turbulences that make it more difficult to fly. Right. The same thing also happens with something called the ground effect, where it generates the ground effect for a drone. Basically, there's no need to go into technicalities. It just means that your drone will actually not be able to take off, and you can have a very bad scenario where the more power you apply to thrust to try and lift it off the ground, the greater it gets sucked into the ground as well. These are things that you must be aware for your environment, your local air conditions. Right? And the last things that you must be concerned about are your GPS, are your signal health. Right? How is your drone able to communicate with your flight controller, with the operator on the ground? Right now, most drones use GPS in outdoor environments to navigate themselves. GPS signal, come on, we've all driven around the CBD. You know how difficult it can be to get your GPS signal sometimes. Right? If it loses the signal after a while, your cars are already problematic enough. Much worse if you have an aerial vehicle up in the air that can actually crash onto the ground. The other item that is important is control unit signal health, which is the radio frequency by which you're able to use you're able to control the actual flight of the drone itself. Signal pollution can result in a lot of issues with the signal fidelity, not just the quality of the video that you will get in your live stream, but also the ability for you to even navigate and use your sticks to control the drone. So we ourselves internally, we conduct tests before every flight to go and ensure that there's no major signal interference and that we have good satellite reception in any local zone. And the final item of note will be operator safety. Now, operator safety is 2 levels. It is the skill of the pilot, which is really something that cannot be developed independently. You actually need to be piloting for a while for a pilot to really understand these things. And the other thing is permits. CAS in Singapore, as similar to other national aviation safety authorities, requires that operators have 2 types of permits. First, an operator permit, which is me as a firm. I have a list of approved pilots that say that they can fly on these particular jobs, right? So that's how CAS vets the ability and the culpability of the firm when it conducts commercial operations. The second thing is an activity permit. So this ensures that CAS knows who is flying where and at what time, and that they don't have any issue with, for example, RSAF flights RSAF has been known to be relatively okay with judging when there should be a flight and when there shouldn't be a flight, and we can conduct operations within RSAF air bases when there's no flight down there. But if they do have operations, they do inform us, and then we are not able to do unattended flights during that time. In summary, if used properly, drones can bring great benefits. They are already able to offer great cost savings. They're able to replace a lot of very dangerous, high access work, right? Which is one of the reasons why we're here. We want to minimize risk to our employees and our personnel when they're up at sites. But because of the current limitations, drones have to be piloted by humans within line of sight for the foreseeable future, and the drone operators the guys who are using the drones bear ultimate responsibility. And it's up to us as drone operators, whether myself or any other companies that employ drones within their own suite of services, to know how to go and analyze the risk on the ground at any moment, such that drones are used safely and that they can be used to enhance all work processes going forward. Right? Thank you. I'm done.
Thank you very much, Dr. Chow.